Okay, so in this video we'll talk about elasticity, which is a very important concept in microeconomics. So in general terms, what is an elasticity? And an elasticity is simply the ratio of the relative change of one variable over the relative change of another variable. And an elasticity is typically abbreviated by that little epsilon, which is a Greek letter for E, epsilon, and we typically use that in order to describe an elasticity. So it is the relative change of one variable over the relative change of another variable. So now a very important specific price elasticity of demand. Elasticity is the price elasticity of demand, and that is now defined as the percentage change or the relative change. I put here maybe relative change of quantity demanded over the relative change of the price. So theoretically, we could use the percentage change as a proxy for the relative change, but there are others too. So, and in fact, there are three ways to calculate the price elasticities of demand. That's the percentage change formula, which is basically what you saw here. Then there is the arc elasticity formula, and then there is the point price elasticity formula. So let's go over them one by one. And let's start with the percentage change formula of elasticity. So again, the percentage change price elasticity of demand is defined as the percentage change of the quantity demanded over the change of price. So we want to know if a firm changes the price, or if a price change occurs in the market, by what percentage does the demand increase? So let's assume we currently have a price of 8 and we lower the price from 8 to 6. So then what will happen is that the quantity demanded will increase from 2 to 4. So a decrease in the price from 8 to 6, that is a 25% decrease, because 25% of 8 is 2, so if we go from 8 to 6, so that is a 25% decrease. So the percentage change of the price is negative 25%. But the increase in quantity demanded is from 2 to 4, that's a doubling, or 100%. So now if we apply the formula associated with a decrease in price from 8 to 6, and then quantity demanded increases from 2 to 4, that means that a 25% reduction of the price leads to 100%, the doubling of quantity demanded. And if we plug in the values, then we have for the change in quantity demanded 100%, and for the change in the price the negative 25%, so we get an elasticity of negative 4. So that is relatively elastic, because you can see that a lowering of the price by only 25% leads to a doubling in the price from 2, in the quantity demanded from 2 to 4. But now let's see what happens if we increase again the price from 6 to 8. Now assume that we decrease the price from 4 to 2, so now we are down there. So now the second scenario is that we lower the price from 4 to 2. So now what happens if we lower the price from 4 to 2? That is a decrease of, it's a decrease of 50%. Here we had a decrease of 25%. And this was an increase of plus 100%. But now if we lower the, let's make that. But if we lower the price from 4 to 2, then quantity demanded only goes up from 6 to 8. And that is only increase of 33 1/3. So that is only increase of plus 33.33%. So the percentage change in quantity demanded is 33.3%, but the change in the price is 50%. So now we get a much lower value of elasticity. And again, the intuition is if we lower the price from 8 to 6, we lower it only by 25%, but that leads to a doubling of quantity demanded. But even if we lower the price percentage-wise by a much higher magnitude, 50% from 4 to 2, then the quantity demanded increases only by 33.3%. So it is a much lower value. So the lower the value is in absolute terms, the less elastic demand reacts. And again, you could already see I'm struggling with remembering that we always need to put a negative sign in front of the price elasticity of demand. But very often for convenience, we just drop that because we know when we talk about the price elasticity of demand, we know that it is negative because the demand function is inversely shaped. Okay, so there's a problem, however, with the percentage formula, and that can be seen if we examine what will happen when we increase the price from 6 to 8. So if you remember, when we decreased the price from 8 to 6, quantity demand doubled from 2 to 4. But now what happens if we increase the price from 6 to 8? So that would be an increase in the price of plus 33.3%. But now what happens is that the quantity demanded drops from 4 to 2, which is a reduction of 50%. So now if we apply that into the percentage change formula, we get an elasticity of negative 1.5. So when we lower the price from 8 to 6, we get a price elasticity of demand of negative 4. But when we go the same way back, we get only a price elasticity of 1.5. So the fact that the downward price change leads to a different elasticity value than its reversal makes the percentage change formula not very attractive in economic theory and applied research. So we just don't like that. So therefore, in order to avoid that we get different elasticities when we lower the price from one value to another and then reverse it again and then get a different value, we have something which is called the arc elasticity. And the arc elasticity is best illustrated graphically. So it is also the relative change, but it's the relative change relative to the midpoint. So let's increase the price from 6 to 8. So from 6 to 8, so that is an increase. Okay, so normally when we have a percentage change formula, okay, when we use the percentage change formula, what we do is we essentially have the new value, I call that n, minus the old value over the old. So when we use the percentage change formula on the previous slide, we set the new value as 8, then we subtracted the 6, the old value, the difference is 2, and then we divided by 6, and this is how we got 1/3 or 33%. So in this case, the new value was 8, the old was 6, and we divided now by 6. And this way we got 33.3%. So the arc formula is basically very similar. We also start with the new minus the old, but then we divide by the midpoint between the new and the old. So in this case, we would also do 8 minus 6, so the numerator stays the same, but now instead of dividing by the old value, which would give us the percentage change, we divide by the midpoint between 8 and 6, which is 7. So now we would get the ratio 2/7. Okay, so that's the idea of the arc elasticity. So now let's apply it, and you can see it already here. So if we increase the price from 6 to 8, the relative change in the price is the new quantity demanded is 2, the old quantity demanded was 4. Now we divide by the midpoint. That is the relative change in quantity demanded. Now let's divide that by the relative change in the price. The new price is 8. The old price was 6. Divided by now the midpoint, 7. And so now we get negative 2/3 divided by 2/7, which is the same as negative 2/3 times 7/2. So the 2 cancels out, and we get negative 7/3. And negative 7/3 is 2/1/3. So this is what we get here. Okay, so now we see if we increase the price from 6 to 8, we get an elasticity of negative 2.33. So if we go back again, so now assume we lower the price. So now we have to look at this one here. So if we lower the price, now the relative change in quantity demanded is, okay, so the elasticity is the relative change in quantity demanded. The new value is 4. The old value was 2 over the midpoint, 3. Now the relative change in price, the new value is 6. The old value was 8. Divided by the midpoint, which is 7. So now we get 2/3 divided by negative 2/7, which is again the same as 2/3 times negative 7/2. So we also get negative 7/3. So the arc elasticity avoids the problem that we get different values when we lower the price and then reverse it again. So, but there's a final problem, which is in economics we barely lower the price from 8 to 6 or increase it from 6 to 8. Those are huge steps. So what we are typically interested in, what happens if we lower the price by just a very little, maybe by from 8 to 7.999. And that leads us to the point price elasticity of demand. So what happens if you are interested in a change of quantity demanded relative to a change in price, but everything takes place in such small numbers that everything fits over one point. So the arc that we had here, basically here, we looked at the change in the price, so you can think of an arc here, and you can think of an arc there. Then we worked with the midpoints, but now we make everything so small that basically everything fits over a point. And that gives us the point price elasticity formula. And in mathematical terms, if you have everything which is very small, then you would write the elasticity, which is generally written as the relative change in quantity demanded over the relative change in price Okay, so this is the basic formula. But now everything is so small that, when we wrote the new minus the old, so it is now so small that we say, if it is so small that it fits over a point, we use the mathematical symbol D. D means just a super, super small change. D stands for difference, but it is very, very, very small. So it is so small, the change in Q is so small that it fits over a point. So that's the idea. So, if you basically, let's say, have a change in price, let's say I make it here, and I would zoom in into this point. So now I have a magnifier glass, so assume this is a magnifier glass, then the change is so small it fits over the point. So that's the idea. So it is basically the arc elasticity, but everything is much smaller than in the arc elasticity. Everything fits over one point. So that's how you have to think about it. And then of course we do the same thing for the change in price. So the difference in the price is so small it fits over a point. So now we get dq over q over dp times p. And if you flip around the denominator, we can write the change in q over the change in p times P over Q. And dQ over dP, we can also think of it as a slope, because what happens is, if you take a look at the slope of, let's say, the demand curve, then how do we get the slope? Well, the slope is generally the rise over the run. So the rise would be this distance here, but this is the change in price, dP. And this distance here is the change in the quantity, dQ. That gives us the slope. But here we have the opposite. We have not dP over dQ, which would give us the slope of the demand curve, but we have dQ over dP. which is the inverse, or the 1 over the slope. So this term can also be written as 1 over the slope of the demand function. So that's why the point price elasticity of demand is typically written as 1 over the slope of the demand function times P over Q. So, and here you see it again. And the way to think about it is that the point price elasticity is essentially the arc elasticity, but we make everything so small that it fits all over a point. Okay, so now we have the formula 1 over the slope times P over Q, or P over Q times 1 over the slope. Okay, so now if we have our example here, so now we can determine the price elasticity of demand at every point. So what is the slope of the demand function? Well, that's pretty easy. The slope is -1. Okay, so now what is the price elasticity at this point here at 10? So then if we use the formula, okay, so the elasticity when the price is 10, so 1 over the slope, so that's -1, times now the price 10 over the quantity 0. Well, that's not defined, so we say this is infinity. And again, the formula for the elasticity is E equals 1 over the slope times P over Q. This is what we just derived. Okay, so maybe let's examine what happens at the price of 9. So then what we need to change, the 1 over the slope part of the equation stays the same, but now we get -1 times 9 over 1. And this would be equal to -9. And you see here where at the price of 8, the point price elasticity of demand would be -1 times 8 over 2, which is -4. And here in the middle, at the price of 5, we would say -1 times 5 over 5. So that's -1. And at, for example, at the price of 2, we would say -1 times the price 2 over 8, which is -1 over 4, or 0.25. So what you can see is if you start on top of the demand function, everything is very elastic, and then the elasticity keeps on going down until it reaches 0 at this point, which is also known as the saturation point. This point is often the prohibition price. So, but the point is that we have two sections of the demand. Whenever the absolute value of the elasticity is greater than 1, then we call that elastic. So this part here, that's the elastic part of the demand function, because a relative change in the quantity demanded always outweighs a relative reduction in price. And actually it's a little bit longer. So this is the elastic part, and the inelastic part starts below the -1. So this would be the inelastic part. And here in the middle, where the elasticity is 1, that is what we call unitary elastic. So whenever the elasticity is greater than 1 in absolute terms, we call it elastic. When it is equal to 1, unitary elastic, and when it is less than 1, it is inelastic. Okay. Okay, so now what are the determinants of the price elasticity of demand? So without going into the math, there are like 4 determinants. The first one is the availability of substitutes. So the more substitutes you have, the more elastic something is. So think, for example, about a certain medication. So let's say you have a certain disease, and God forbid that this is the case, but just imagine, and you depend on a medication of which there is only one. And so there's only one medication available for you, so no substitute. Well, obviously, if your life depends on this medication, your demand is very inelastic because there are no substitutes. So what can you do? So you have to have that medicine, even if it becomes very, very expensive. So the more substitutes there are, the more elastic it is. So for example, the price elasticity of demand for fruit is very elastic because, let's say, there are apples and pears and oranges and banana and pineapple, and you can all substitute that. So that makes something more elastic. The second determinant of the elasticity is the kind of the goods. So if it is a necessity, like that medication, it is inelastic. But if it's a luxury good, it's typically elastic. So a necessity is inelastic, and a luxury good would be highly elastic. So if you think of a luxury good like, vacations, like cruise ship vacations, that would be a luxury good. So if the price goes down, the demand for it will increase a lot. But for something which is a necessity, like something that you cannot live without, it's very inelastic. So the third determinant is the price relative to income, and the greater is the share of the expense of a good relative to income, the more elastic it is. So think about it. Let's say you like nice pens, and there are, let's say, beautiful pens that cost maybe several $100s. Let's say, and if you have put your eye on a certain pen, and it costs like, a lot, let's say $500. But now it is on sale for, let's say, $450. You may actually think that, now I buy that pen that I like so much. Or the same thing with, let's say, a car that you like very much. So if it takes up a high share of your expenses, then, a little reduction in the price, percentage-wise, of course, makes in absolute terms a big difference, and that induces then people to buy. So again, if you go back to that example of the pen, let's say the pen costs $500, and now the price is reduced by 10% to $450. Yeah, you think, okay, now I can save $50. You buy it. But let's say if you go to Walmart and you want to buy a new regular yellow pencil, which costs maybe $1 or 50 cents, and Walmart has a special on the pen, and it reduces the price from 50 cents to 45 cents, you don't necessarily get super hyped up that you need to have that pen right now. So when something has if something assumes a great share of your income, then it is more elastic. And a final determinant is time. So over time, demand tends to become more inelastic over time. And that is largely because of more competition that drives down the price. The way you should think about it is that, we already introduced demand and supply analysis. So, if you have a market demand function, so now we know up here we have all the elastic things. So let's say this is the supply. But now over time, if there is more competition, the supply shifts to the right, and maybe the market leaves here where the market demand is very inelastic. So that's a little bit the reasoning behind. I personally don't like that argument too much, even though it is quite present in textbook, because sometimes you might think, well, over time, maybe also more substitutes become a bit more available. And then if you have more substitutes available, things become more elastic. So you always need to elaborate a little bit more if you talk about time and how it affects elasticity. In my opinion, it could go in either direction. Okay, so those are the determinants. So let's talk about some other elasticity. So far we have only talked about the price elasticity of demand, but there are other elasticities too. So there's the income elasticity of demand. So that's the relative change in quantity demanded over the relative change in income. So it's no longer anymore the price, so we replace price by income, and then it becomes the income elasticity of demand. And now if you remember, we talked about two kinds of goods, normal goods and inferior goods, and we said a normal good is one when the income goes up, quantity demanded or demand goes up. So in this case, if this goes up and this goes up, then we have a positive relationship, and we know, well, this must be a normal good. But if we have the other case, and let's say the relative change in income goes up, but now we demand less of a good, maybe what happens maybe with instant noodles, so then we have an inverse relationship. The resulting elasticity is negative, and that would correspond to an inferior good. Okay, so could be either one, could be positive or negative, and this is something that we of course observe in practice. So let's go through a hypothetical example. Why knowing the income elasticity of demand is important. And let's assume that the country wants to help the poor who presumably eat a lot of basic staple like potatoes or rice. But if the government is under the assumption that even of the basic staples people don't get enough, they should eat more. So now the government, let's say, launches a program that gives a cash transfer to those very poor, which increases their income. And the hope of the government is that they use that money in order to have more potatoes and rice. So the government wants to increase the real income of the poor people by sending them a cash transfer. And now we need to look what happens in the market. So if then the demand for the basic staple goes down and demand for a normal good, like for example beef, goes up, the basic stable must have been already an inferior good, and the income subsidy is ineffective. Because what did people do? They said, okay, now I have the extra cash. I'm not that hungry anymore that I need to eat more potatoes or rice. I finally can leave that behind me and I can start eating strawberries and mango or beef, something like more expensive. So in this case, specifically, such an observation would suggest that people seem to be less poor or less food insecure than what government has anticipated. So knowing about elasticities is important from a public policy perspective. Okay, there is also a price elasticity of supply. So the price elasticity of supply is the relative change in quantity supplied over the relative change in price okay. And it's basically the same formula. You can derive it as 1 over the slope times P over Q. I'll make here a little S of quantity supplied. So let's take a look at this first supply function, which starts here at 4. So if we apply the same formula here at 4, we would say 1 over the slope. What is the slope? The slope here is 1, positive 1, so the slope is positive 1. So 1 over positive 1, that's 1. But 4 over 0 is again infinity, and very elastic. What about at the price of 5? Again, 1 over 1, that's 1, but then we have 5 over 1, elasticity is 5. At the price of 6, we would do 1 over 1 times 6 over 2, which is 3. And then here maybe at 9, we would say 1 over 1 times 9 over 5, which is 1.8. But you see that the elasticity, as we increase the price, decreases. Elasticity goes down, decreases. Okay, so it's a little bit similar like with the demand. The more we move along the demand from the y-axis, the more inelastic things become. But there is an exception, which is if the supply function goes through the origin, then the elasticity is everywhere 1. So just think about it here. I have now a different slope. The slope here is 1 over 2. So what I do is I do 1 over the slope. So this term is always 2. And then what do we have here? 2 times price over Q, 1 over 2. So times 1 over 2, which is 1. Then 2 over 4, which is again 2 times 1 over 2. Then at 3, 3 over 6 is again 1/2. So it always cancels out, or it doesn't cancel out with that. So the ratio, this term here, P over Q, this term is always 1/2. So that is a specific case. Okay, so let's move next to a couple of other elasticities. There is also the cross-price elasticity of demand. And the cross-price elasticity of demand captures the relative change in quantity demanded of good A, or for good A, over the relative change in price of good B. So let's think about two goods that are maybe substitutes. Let's think of maybe apples and pears. So what do we know already if the apples and pears are substitutes? If the price of apples goes up, then what happens is that people eat less apples and then they substitute them by the pears whose price didn't go up. So again, we always hold everything else constant. So that means that the demand or quantity demanded for pears goes up. So in other words, when the price of good B, which is let's say apples, goes up, and the quantity demanded of the other good, which is in our case pears, go up, so positive, positive, we get a positive relationship, then we must have complements. Okay, I'm sorry, substitutes. Like apples and pears, obviously, substitutes and complements. So when it's positive, that complements substitutes. Substitutes. Okay, but now let's turn to complements. So let's say we have complements like peanut butter. So let's say the price of peanut butter goes up. Then what do we observe for the quantity demanded of, let's say, jelly? So when the price of peanut butter goes up, then the people buy less peanut butter, and if they eat less peanut butter sandwiches, they also put less jelly on it. So the demand for jelly goes down. So in this case, we have an inverse relationship. And whenever this is negative, then we have complements. Well, and if, let's say, the elasticity is 0, well, that just means that the two goods are unrelated. So let's say, if I want to ask the cross price elasticity of demand, if I want to know if the relative change in price for rubber boots goes up, then the relative change in quantity demanded for milk is probably not affected, and they are then not in the same market. So by the way, the cross price elasticity may play an important role in in competition law, when somebody needs to decide, does a certain merger create too much market power? And let's say if a big company like Coca-Cola wants to acquire Pepsi, then maybe the competition policy authority may say, which is the Federal Trade Commission, they may say, you know what, we don't allow that merger because it will generate too much market power. Well, then the lawyers of Coca-Cola, they may then try to argue that the cross-price elasticity between Coca-Cola and Pepsi is 0, and that they don't belong to the same market. So, like in those kind of applications, the cross-price elasticity often plays a role. So the cross-price elasticity can be used in order to determine whether two goods belong to the same market or not. Okay, so there's a final important aspect associated with the elasticity, which is the relationship between the price elasticity of demand and revenue. And let's say a company operates on the elastic part of the demand function. So assume that initially we have a price of 8. Okay, what happens at the price of 8? So when price equals 8, total revenue is 8 times 2, 16. So now we lower the price to 6. When the price is 6, what is total revenue? So the total revenue is now 6 times 4. So what happens is that total revenue has gone up. So in other words, whenever you operate on the elastic part of the demand function and you lower the price, then total revenue goes up. So, but now what happens if you lower the price from, let's say, 4 to 2? So you operate on the inelastic part. So if the price is 4, then total revenue is 4 times 6, 24. So now we lower the price to 2. And total revenue is 2 times 8, which is 16. So now total revenue goes down. So that's important to know, and it can also be illustrated. So here total revenue goes up by plus 8 from 16 to 24. That's an increase of plus 8. And here it would be a decrease of negative 8. Okay, so where can we see that 8? Well, if we lower the price from 8 to 6, so then initially at the price of 8, we had, let's insert quickly. So at the price of 8, this is the total revenue. Okay, let's make that a little bit transparent. Okay, so this is the total revenue associated with the price of 8. At the price of 6, total revenue is this. Okay, let's make that green. Okay, let's make there some transparency. Okay. Okay, so now you can see this green one is the new total revenue, and this one was the old revenue. So what happens is we obviously lose in the old revenue the upper red part. So that is a loss of 1, 2, 3, 4. But then with the new price we gain this green area here to the right, which is 2, 4, 6, 8, 12, 2, 4, 6, 8, 12. 1, 2, 3, 4, 5, 6, 12. So we get a gain of 12, 2, 4, 6, 8, 10, 12, but we lose those 4, which gives you that gain of 8. Okay, so now let's do the same thing. When we lower the price on the inelastic part, so this is our total revenue associated with the price of 4. And this green area is now the total revenue associated with the price of 2. So now you see, now we lose this upper part, which is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. But we only gain 4, so that leaves us up with a net loss of 8. So a decrease of the price on the elastic part of the demand curve increases revenue, so that is what we have seen here. So if we decrease the price on the elastic part, we can increase the revenue. But if we decrease the price on the elastic part of the demand function, we can increase revenue. But if we decrease the price on the inelastic part, then total revenue will go down. Okay, so this is the concept of elasticity. Again, if we quickly summarize, so what you should know now is the different forms of the elasticity. So elasticity is generally the relative change in one thing over the other one. Then we talked specifically about the price elasticity of demand. We talked about the percentage change formula. We don't really like the percentage change formula because we get a different elasticity when we lower the price from one to the other than what we get if we go back to the old price. Then we have identified the solution for that problem, that was the arc elasticity. But then the arc elasticity involved like price changes that are really huge, and economists are typically interested what happens in the marginal. So that's when we introduce the price elasticity of demand. And again, the price elasticity of demand is essentially a specific form of the arc elasticity. Then we talked about various forms of elasticity. So we also talked about the income elasticity. So we can use the income elasticity in order to determine whether something is a normal good or an inferior good. Then we talked about the income elasticity of supply. We talked about cross-price elasticities, which can be used to identify complements and substitutes. And last but not least, you should have an idea of what the relationship is between total revenue and elasticity. Okay, so I hope that this has helped.